Assalamu alaikum guys. We have been doing an ECG discussion series on Telegram social media since the last few months, and few of them messaged me that they are not able to pick up those basic findings which we used to point out. And one of them recently messaged that, why don't you try starting a YouTube channel? So I thought let's give it a try, and if it goes smooth we'll try to continue these videos. And if you don't understand what I'm saying, you can comment them below. We'll try to make another video on those topics. If I make any mistake, you can comment them as well. We'll try to redo the video, and we'll see how it goes. So let's begin. So I just wrote down the things what we need to look while reading an ECG. We'll be covering each topic in the later videos, but I'll try to cover a few of them in this video itself. So first thing is the standardization, that is the calibration what we look. Then heart rate we need to see if there is any arrhythmia. If there is an arrhythmia, then we have to see if there is any difference in atrial and ventricular rate. Then the rhythm, the cardiac axis. Then we have to look for each waves as well as the interval, that is P wave, then PR interval over the segment, Q wave, then the QRX complex itself, then QT interval or the corrected QT interval, QTC, then R wave progression, then the QRS voltage, then the ST segment, then T wave, and last U waves. We'll try to find out if there is any abnormality in these waves or segments or any cardiac axis. Then we'll write it down in this manner. Then we'll analyze the whole thing and try to give a provisional diagnosis. Let's begin with the standardization of the calibration. I'll be talking only about the superficial part of these topics. So only two things you have to look into. That is this, that is how much of deflection does 1 millivolt produce. So over here if you see the height of this small square kind of thing is 10 mm. Okay, in the ECG machine you can actually calibrate into 5 mm. 1 millivolt is equal to 5 mm or 10 mm or 20 mm. We'll not talk about all this. What we need is 1 millivolt should be equal to 10 mm. Okay, similarly second thing what you have to look is what's the speed at which the ECG is being printed. So if you see over here it's printing at 25 mm per second. You can actually make it slower or faster, but the standard one what we require is 25 mm per second. So if you see these two things, 1 millivolt is equal to 10 mm and the speed at which the ECG is getting printed, that is 25 mm per second. This is all what you need to know in standardization. So let's move on to the next. Let's go into heart rate. So before that I just want to explain that we had calibrated the ECG machine at a speed of 25 mm per second. So what does this mean? If you see one big box over here, it is actually 5 into 5 small boxes. 1 mm is equal to 1 small box. So what does this mean? 25 mm per second means it is moving at a speed of 25 small boxes in 1 second. That is equal to 5 big boxes per second. That's clear? Why I'm saying this is because when we say heart rate or pulse rate, we are actually saying these many beats per minute. So we have to convert these 5 big boxes per second to 1 minute. How do we do that? That is 5 big boxes into 60 will give you how many big boxes per minute? That will come around 300. And if it was smaller boxes, it will be 25 into 60 will give you around 1500. Okay. So to calculate the heart rate, we are actually seeing the number of big boxes in between these two RR interval. So if you see these two RR interval, there's a box over here, big box over here, another big box over here, and a half big box. So this is around 2.5 big box. So heart rate is equal to 300 divided by 2.5 is equal to 120. This is the heart rate. If you are looking at small boxes, it will be around 5 and 5, 10 plus around 12.5, 12 or 13 small boxes. So if you are taking the small boxes, you will have to divide 1000 divided by 12.5. Okay, that will be around 120 only. So that's how you see heart rate. Moving on to rhythm, this is very simple. Just have to see the rhythm strip at the bottom over here. It can be either lead 2 or V1. What you have to see is the number of big boxes or small boxes in between each RR interval. You can calculate the boxes in between each RR interval and compare with the other RR interval in the rhythm strip, or you can keep another paper over here and mark the QRS deflections on the paper and slide the paper throughout the rhythm strip and compare the RR interval. That's it.